Hi, Mimi. So this is just me sort of finishing up the problem from before with you. We ran into a bit of trouble where we weren't quite sure what to do. But actually, there's a pretty simple trick that I kind of can't believe we didn't think of as we were going through it. But it is a little weird, so we'll work through it together. If you're really only interested in the end, you can kind of skip a couple minutes into the video, but I'm going to walk through step by step. So first of all, we can rewrite our expression up here as 2 raised to the 4 minus y plus 2 raised to y equals 10, because this x plus y equals 4 can be rewritten as x equals 4 minus y. So we're just doing basic substitution with x here. Now this 2 raised to the 4 minus y can be rewritten as 2 to the 4 over 2 to the y. And from here, we can simply multiply everything by 2 to the y. This gives us 2 raised to the 4 plus 2 raised to the y squared equals 10 times 2 to the y. Now, we can rewrite this again, just simplifying basically, and by subtracting this 2 raised to the y squared over to the other side, we get 2 raised to the 4 equals 10 times 2 raised to the y minus 2 raised to the 2y. From this point, we can just rewrite our 2 raised to the 4 as 16. So we get 16. Oh, and also sort of factoring out this 2 raised to the y. So we get 16 equals 2 raised to the y times 10 minus 2 to the y. Now at this point, I felt like we could do some sort of zero product property stuff, but I wasn't quite sure what we were going to do. The trick is if you substitute 2 raised to the y for a, you actually get a quadratic, which you can solve using factoring or completing the square or using the quadratic formula or a whole bunch of techniques. So we get 16 equals a times 10 minus a. And then distributing the a through, we get 16 equals 10a minus a squared. From here, we simply subtract the 16 over, rewrite a bit, we get negative a squared plus 10a minus 16 equals 0. And now if we multiply both sides by negative 1, it doesn't change the solutions, but we get a squared minus 10a equals 16. This is pretty easily factorable as a minus 8 times a minus 2 equals 0. You can set each piece equal to 0 because of the zero product property, which means that we get a equals 8 and a equals 2. So at this point, we just remember that a equals 2 to the y. So we resubstitute and we get 2 raised to the y equals 8 and 2 raised to the y equals 2. You can solve this using logarithms and using log rules. You would get y equals log of 8 divided by log of 2. But it's pretty easy to see that the number you have to raise 2 by to turn it into 8 is just 3. And the number you have to raise 2 by to turn 2 into 2 is simply 1. So y equals 3 and y equals 1. These are two of our potential solutions. Now, we just remember one of our original equations, which is just x equals 4 minus y. We substitute each value in, and we get our x values of x equals 1 and x equals 3. So we have 4 different solutions. This seems a little odd to us, but if we look back at our original equations, x being, we kind of have a symmetry going on here, which is a little strange, but in either case, we kind of share x and y values, and if you substitute either pair in, you will get the proper solution, right? So I hope that was helpful. Feel free to message me with any further questions, but I just wanted to clear this up for you so you didn't have things left unsolved. All right, thank you, and have a good rest of your day. Bye.